No, that's done. Make a video. Okay.
Hi.
Hello.
Hi, how are you?
Good. How are you?
I'm doing very good, thank you.
Yeah. Actually, this is our first class, and we haven't registered for the class. And Miss Dai say, well, we can try the first lesson and see what's going
Yeah, sure. Yeah,
on. Okay.
you are
Okay. Thank you.
welcome.
Just need to know. So,
Yes.
does kid need to turn on the video or turn? Do you have
Uh,
any request
any request?
for the video on or off?
No,
For
that's completely fine. I prefer that it is on so I can see the students and
okay.
the students
Okay.
can
You
see
can
me. Yeah, so it's like more active reactions, communication between the teacher and the students. Yeah,
okay. Okay, so you will instruct the class today? I'm sorry, I have many questions.
it's completely fine. Yeah, do you have a question right now?
Yeah, I mean, so you will teach us.
I will teach, yeah.
Oh,
I
okay.
will teach this course. Yeah, my name is Muhyiddin Swedan. I'm sorry I didn't introduce myself. My name is Muhyiddin Swedan, and I'm going to teach this course.
Okay, thank you.
Yeah. Hi. Okay, I think we can start now. I want to make sure that everyone hear me before I start. Okay. Anthony, do you hear me?
Yeah.
Perfect. Ethan, do you hear me?
Yes.
Very good. Okay. First of all, I would like to introduce myself. My name is Muhyiddin Swidan, and I'm going to teach you Algebra 1. So we are going to meet every Saturday, as you know. If you have a chance to look at the syllabus, we are going to meet every Saturday from 3 to 4:30, and we will go over the material from the textbook uh, for the fall. There will be like 16 meetings. We will try to cover the first 6 chapters, 6 chapters over the fall. Okay. First, I would like to double check with you, with all the students, that they have their notebook, and if they can turn on the cameras so I can see the students and you can see me, and the communication will be more easier. And also, what else? Yeah, I see. Thank you very much. Okay. Do you have any concern, any questions so far before we start over the material? Do you like math? Not that much? Why? You can unmute yourself, Anthony,
Oh,
if you want to say something.
yeah.
It's completely fine if you want to unmute yourself, as long as we have a quiet room, except when you have any questions, yes, sure, you can ask me directly, now and anytime. So yeah, I just asked if you like math or not. Is it?
Yeah.
Yeah, good. How about Ethan? Do you like math?
It's okay.
It's very important. You need to know that math is very important. You know that the math is the language of other sciences. So by learning math, we can know how to communicate with other sciences, like the science, the physics, chemistry, and so on. So, okay. Austin, do you have any comment you want to say something about math? Do you like math?
Sort of.
Sort of. Okay, that's fine. I hope that you will like my way of teaching. My goal is to make sure that every one of you understand the material and can work independently in the future. And also another goal that I have, I want to make sure that everyone has any question, anytime, just need to ask me, okay? We are learn and we need to ask. And one way to understand and to learn is to ask, okay? So let me start. Today we'll cover the first 3 sections from chapter 1. And chapter 1 is concerning solving linear equations. So every time when we read the title, we need to just look at each word. For example, solving linear equations. Here we have like 2 parts of the title, solving and linear equations. So we need to see if we understand what we mean by linear equations and what we mean by solving. Hopefully by the end of this lesson, we will know what we mean by these words. Okay, first of all, we have something very important in math. It's called an equation. Okay, the equation is called a statement. So it's like words that 2 expressions are equal. So when we have 2 expressions and these 2 expressions are equal, then we call this statement equation. Let me clarify what I mean by that. I just need to open a new page pretty quick. Yes. So for example, guys, do you know that if you have a notebook and you can write with me, that will be perfect, okay? And please, if there's something not clear for you, please just let me know. Okay, so algebra. Oh, sorry, I think it's fine. Algebra. This is the name of our course, right? It's a branch in mathematics and it's concerning with three things: with numbers, and variables, and the third one is operations. Okay, so every time we are talking about algebra, we mean numbers, variables, operations together. I think all of you know the numbers, right? Who can give me an example of numbers? Any number, just come in your mind.
1.
1, yes, that's a nice example. 1. Other examples, please. 1 is like simple number, right? How about fractions? Any example of fractions? We try 1, and if you have an example, please let me know. 3/7, 3/7. This is also numbers. How about negative numbers like, oh, sorry, like -5. So all these numbers and other numbers, there's an infinite number of numbers we have, okay? These are just one part of the algebra. So we are just talking about the algebra. The second component of the algebra is the variables. And the variables are just letters, the English letters, A, B, C, X, Y, whatever, all these numbers, small letters or capital letters. Like for example, I can say X. X is an example of the variable. And simply what we mean by variable, it's just a letter that expresses unknown quantity. When I know that I have 3 friends, I can say 3. But if I don't know how many cars are outside, then I can donate the number of the cars because they are not known for me. It's X or Y. So we use these letters, X, Y, Z. I mean by this letter Z, okay? I used to write it in this way. Are you familiar with this notation? Z, okay. A, and so on. So these are just an example of the variables. And the third component, the operations. We always work with operations, right? We have 4 basic operations. Do you remember these operations, guys? The first one is Austin. Do you want to share with me the first operation? Yes?
Addition.
Addition, thank you very much. Yes, the addition. And subtract, or subtractions, thank you. Multiply, or multiplication. Oops, I just need to use that. Sometimes we use X, or the multiplication sign. We have several ways to express the multiplications. And the division. There are other operations like square root, squaring, raised to the power 3, but these are the basic operations. Okay, so far everything is clear? So every time we are talking about algebra, we mean numbers, variables, operations. Okay, if we go back very quick and look at the first definition we have in the first slide here, it's the equation. It's a statement that 2 expressions are equal. So what we mean by expressions? Okay, let me just change the color very quick. Yes. Okay, now when I'm saying expression, this is in fact, it's just a combination. We mean by expression in math is just a combination, any combination of the numbers, any kind of numbers, variables, and the operation. Okay, so if you just think by any combination, any mix of these three parts, the numbers, variables, and operations, if you combine them together, you will get an expression. I will give you one example. Number one, I'm thinking with 3x plus 2y. This is just a particular example for the expression. I can see the numbers. You see the numbers, guys, here? 3 and 2 are the numbers. How about the variables? Yes, x and y. So I see also the variables. And the operations, I clearly see the plus here. But remember, 3x means 3 times x. Sometimes we multiply and write the operation or just leave it as 3x, and we understand that 3x means 3 times x, okay? Now, it's not necessary that every time all the numbers are shown in the expression or all the variables or all the operations. You see this expression does not have division or subtractions, which is okay. We still have an expression, okay? What else? How about 5 minus 2x all over 7? Now, this is another example for the expression. We have 5 minus 2x over 7. The numbers are 5, 2 or -2, and 7, right? X is the variable, and the operation are just the minus here and the division. Do you see the third operation, guys? Yes? Which is? Anyone would like to answer? I see the minus, subtractions, the division. Where is the third operation?
Multiplication.
Multiplication. Thank you very much, Nathan. Thank you. Yes. So these are just two particular examples for expressions, and we have a bunch of examples for expressions. Okay. Now, this is just explain what we mean by expressions. Now, how about the equations? If you go back, to the definition of the expression, the equation, it is just a statement that two expressions are equal. So every time we have equality of two expressions, for example, 3x plus y, and for example, the other expression 7 minus 2y. Now I see I have expression 3x plus y, and the other expression 7 minus 2y. These two expressions are equal. That means that we have equations. So the whole sentence expresses an equation. And now this particular equation consists x and y. So we can say this is equation of two variables, which is x and y, okay? Now, the good thing in this section and the other sections, we will just looking and concerning the equations with just one variable. So that is under the linear equation in one variable. It means that we are talking about one equation that can be written in the form ax plus b equals 0. Here we have one variable, which is x. A and B are, it seems that they are letters, but they are donated for numbers, because we are given here a condition says A and B are constant and A does not equal 0. So guys, anytime we have an equation in this form, we mean this is an example of linear equation in one variable. So again, ax plus b equals 0. I will just play with the a and b and give any kind of numbers. We just change the color so it can motivate. How about the red? Okay, so one example, 3x plus 11 equals 0. Do you see what I'm doing? I'm just rewriting this form, ax plus b equals 0. I just change a and b and give some numbers, 3 and 11, for example. So 3x plus 11 equals 0. This is a linear equation in one variable, which is x. What else? We can consider negative 2.1 x minus 7.3 equals 0. This is another example for the equations. Here a is negative 2.1 and b is negative 7.3. Okay? Do you have any questions so far? Is that something easy or familiar? Have you seen this before? We'll just start with the section and see, we'll get some other ideas to cover. Now, every time we talk about equation, we need to consider an important concept, which is the solution. A solution of the equation, it is just a value, a number that makes this equation true. So when we're looking at equation like 2x minus 8 equals 0, we are just curious about the number that makes this equation true. Does there exist a number that makes this equation true, or there is no? Can you think with me, guys? Can you think of a number that I can plug it in this equation and make the two sides are equal?
4.
1. Okay, let's try. I will just replace x by 1. So I have 2 times 1 minus 8 equals 0. So I just rewrite the equation again and replace x by the value, the assumed value 1. Now, we know that 2 times 1 is 2. 2 minus 8. You think 2 minus 8 equals 0? 2 minus 8 is negative 6. But negative 6 clearly does not equal 0. So what does that mean? That means that this number, x equal 1, does not make this equation true. So it's not solution, right? So we say that x equal 1 is not solution. Okay. Let me think with another number. At first, I will move to get some extra, or we can erase this. Are you done with this part, the blue? I just want to erase it. Okay. Still writing? Okay. How about x equal, can you guess another number, guys?
4.
1? We already did tried the 1.
4.
4. Oh, yeah, that's correct. So again, the equation is 2x minus 4 equals 0. And we assume that x equal 4 is the solution. We need just to check the solution. So I'm going to replace x by 4 minus 4. It is, I think, 8. I'm sorry. The original equation was 2x minus 8. So 2x minus 2 times 4 minus 8, does that equal 0? I'm just trying to check the number. This is 8 minus 8, and this equals 0, and that's true. So we say that x equal 4 is a solution. By the way, x equal 4 is the unique solution. It's the only solution we have. Okay. Any questions so far? The other thing that we need to discuss is the inverse operations. We need that the inverse operations are just two operations that undo each other. They cancel each other. For example, the addition and the subtractions, multiplication and division also. Another example for the inverse operations. These are just like some basic concepts we need to know before we go over the solutions. So if we move for the first part, yes, it's 1.1.1. We are now going to learn how to solve the equations by just adding or subtracting. But before we see how to solve, we have only we have two properties that can help us to do that. The first property is the additional property of equality. It says that if we are given that A equal B, then simply we can add the same number C for the two sides. It's allowed. We can do that in mathematics when we have every time we have equations. Also, for the subtraction of property, we can also not only add, we can also subtract the same number. Be careful, we need to subtract the same number every time we work with equations. And we pretend that these two properties can help us to solve equations that have the addition or subtractions. We just need to do the inverse operation every time. Okay, so this is an example. It says, for example, A, it says x minus 3 equal negative 5. Oh, sorry. So x minus 3 equal negative 5. Because I have negative 3 here, I'm going to add. To cancel the negative 3, I need to add. So you need to think and ask yourself, what's the inverse of minus? It's a plus. So I need to add the opposite number or to undo the operation so I can cancel it and solve the equation. We claim that we can solve the equation when we do that. So minus 3, if you just add 3 to the both sides, what we will get? X minus 3 plus 3, these will cancel each other and we will left with X equal negative 5 plus 3, it's 8, negative 8. Can anyone share this with me? What do you think? Negative 5 plus 3?
Negative 2.
Perfect, yes, it's negative 2. So, wow, what we have? We just get x equal negative 2. I mean, we already find the solution. X equal negative 2 is the solution. We claim that x equal negative 2 equals solution. So this kind of equations, we just need to do one operation to get the solution. But we need to be smart. Just look at the equation and decide, do I need to add or do I need to subtract? Because I have minus 3 on the side of x, then I need to do the inverse of minus 3, which is a plus 3. So plus 3 will cancel out the negative 3, and we left with x equal negative 2. So x equal negative 2 is the solution here. And if the question says, check your answer, you just need to plug negative 2 in the original equation. You should get the same number. Let me do another example. How about C? It's n plus 3 equal negative 7. Okay, so I have plus 3, just adding 3 to the n. Because I have a plus 3, I need to think, what is the inverse operation of a plus? It is simply minus, right? So I just need to subtract the same number. And because I did this on the left-hand side, I have to do it on the right-hand side as well. Now, the benefits of subtracting 3 from the two sides, on the left-hand side, I will cancel out 3 with minus 3, and that means I will be left with n. And for the right-hand side, I have negative 7 minus 3. I can do it mentally. Negative 7 negative 3 will be negative 10. So n equal negative 10 is the solution of the original equation. And then we are done here. Okay? I'll just give you 1 minute to go over solution. And please, if you have any questions or something you are not sure why we did that, please let me know. Okay? Any questions so far? Everything is clear? I think you are familiar with this, right? Addition, subtraction is something like that. It's like the basic, the most easiest way, just to add if we have minus. If it is a plus, I'm going to subtract. Okay. If you are done writing and you don't have any questions, we can move to the next idea. So we're just looking at adding and subtracting. But sometimes I need to do the other operations, multiplication, division. I don't have plus, I don't have minus. I have multiplication or division. Then what should I do? Okay. If you look at this idea here, again, we have another two properties. For the multiplication, I have for the multiplication and for the division. I can, if I have A equal B, then I can multiply, you see, the two sides by the same number. So that's allowed in mathematics. You can multiply the two sides by the same number. Not only that, I can also divide. So if A equal B, then I can divide the two sides by the same number. But be careful, because we are not allowed to divide by 0. We exclude the 0 from the values of C. So I can divide the two sides by any number, by any non-zero number, except the 0. Okay? These are the properties. Now, we need to try to see, can we apply these two properties to solve the equations in the examples from A to D? I see, for example, part A. We have 1.3, this is a decimal, Z, it's multiplied by Z, and this is equal 5.2. So I don't see addition or subtraction now. I have what? Multiplication, right? It's multiplied. So I can apply the division property of equality. I can divide the both sides by the same number, but I need to be careful and see which number I need to use here or to apply. Because the Z is multiplied by 1.3, then I'm going to divide by 1.3. And the reason why we divide the two sides by 1.3 to make Z alone. Now Z is multiplied by 1.3, so the idea here, I need to divide by that number, okay? Now 1.3 Z over 1.3, these two numbers are cancel each other. Do you see what we left with? Z. So Z is the left-hand side. This is what we get after we divide both sides by 1.3. Now for the other side, 5.2 divided by 1.3, this is 4. So that is the solution. You see, every time we get the solution, we end with the variable only on one side and a number on the other side. In order to say that this is the solution, then the variable should be in one side and the other numbers on the other side. Okay? Do you see what we did so far? Do you have any questions so far? No? Sure? Okay, I'm going now to ask you guys to help me to do part C. It's negative n over 5 equal negative 3. Let me just write it again. negative n over 5 equal negative 3. Okay, I see that the negative is in the front of the fraction, but now here it's just beside to the n, and that's completely fine. Let me show you something. I will write it on the margin here. Do you know, guys, that negative 1 over 2 is equal to negative 1 over 2? It's also equal to 1 over negative 2. This is a fact that I can use it anytime. Which form do you prefer? You can just pick it and apply it. You can write the negative outside of the fraction, or in the numerator up, or in the denominator down. It's up to you. So this is what I did so far in part C. It was negative n over 5. I just write it negative with n, so it's negative n over 5 equal negative 3. Now I see that I have divided, do you see this, guys? Divided negative n by 5. So I need to think, what is the operation that I have and what I need to apply? Which operation I need to apply? Yes? Dividing, right? So I'm going now to multiply. Multiply the two sides. Because I'm dividing by 5, then I need to multiply by 5 both sides. But because I also have minus with the n, I need to cancel out this operation. So it will be better or make more sense if it make it negative 5. Okay, so in this case, 5 will cancel with 5, negative will cancel with the negative, then we left with n equals negative 3 times negative 5. Okay. Oops. So it's negative 3 times negative 5, and this is negative with negative will cancel each other, and 3 times 5 is 15. So this is the solution now. Since n is in one side and a number on the other side, then we are done. This is the solution. Okay? Any questions? Is that easy? You can just shake your head if you want. Is that clear, guys? Ethan, Anthony, Austin, any question, guys? You can unmute yourself if you want to say something. Okay. Okay. Let us now move to something called in math word problems. Word problems means that we have a problem that we need to read, understand, and then translate it to equations, and hopefully we can solve it. Okay, so I will go over the example here. It says in the 2012 Olympics, Usain Bolt won the 200 meters dash with a time of 19.32 seconds. Now, because we are mathematicians, usually the numbers attract us. In other words, when we read a sentence, we look or focus at the numbers. So I see that there's 200 meters. This is distance, right? I can denote it by D for the distance. And with a time of 19.32 seconds. So this is time, right? So I can denote it by T. Now, what's the question? It says write and solve. So I need, guys, first to write and solve an equation to find this, to find his average speed to the nearest hundredths of a meter per second. Okay. So we need just to recall what we mean by speed. We know that speed, there's a formula describes the speed is equal the distance all over the time. So in other words, if we are going to use the letters, the speed, I will denote it by S. It's equal to distance, which is d, all over the time, t. Yes, this is one formula that we always use it whenever we are trying to find the speed, and the distance and the time are provided. Now, what we need to do, and by the way, this is the equation, guys. S equal d over t is the equation. I just need to plug the values of the distance. It's 200, right? All over the time. And the time here is 19.32. So if you have a calculator, you can just divide the 200 by 19.32, and the answer is 10.351, because the question says to the nearest. Do you guys read the question? To the nearest 100. 100 means just find the number or the answer for just the first two decimal places. So I will stop at the 5, and because the third digit is 1, it's less than 5, so it doesn't give, it just turned down. Now this is the answer, it's the S, and this is the average speed. I just need to write the unit. The distance unit is meter, the time is seconds, and I'm dividing distance over time, so the average speed will be meters per second. This is the unit of the speed. Okay? Please, if you can write this in your note, and if you have any question how we get the answer or any question about the numbers. Okay. Are you done, guys? Is it clear? So keep in your mind every time you have a word problems, and I know as students, the most hard questions are the word problems, that the question has too many words. Wow, I need to read, I need to understand the question, I need to know what is given and what the question asks me to find. So I know it's not one-step solution. There are several steps that I need to work on to get the answer. But as an advice, every time you have a word problem, just read it 1-2 times. Make sure that you understand the question. You know what is given. We are given the distance. We are given the time. And what is the question asking me to find? The average speed. So I need to find a relation between the distance and the time and the average speed. And we know that. So just need to plug and calculate, simplify, and we get the answer. Okay, and this is actually like the most important things in the first section. We will move now to section 2, which is solving multi-step equations. Now, it's nothing new here. We just need to apply several operations at the same time. I have to add and multiply, divide and subtract, and so on. So usually every time we have equations, we need to find x, the solution, right? Keep this in your mind, guys, that every time we need to solve. Solving means to find the solution. And the solution means x equals something. Okay? So let us do some example and see what we mean by the multi-steps. Multi-steps means that we have many steps we need to do before we get the solutions. I will do part A, for example. I have 2.5x minus 13 equal 2. What I see here, that I subtract 13 from 2.5x. Not only that, I multiply 2.5 by x. So I have subtract and I have multiply. So I need to do the inverse, correct? So the first step here is to find the inverse of the minus subtractions. So I'm going to add 13 to the both sides. You see, guys, I just applied the additional property for equality. Now, minus 13 plus 13 cancel each other. This will be 2.5. I will give myself enough space. X equal 2 plus 13. This is equal 15. Okay. Now, the good thing here that I did one step and I get a similar form of the equations. I still need to find X. So the first step just helps me to get rid of the negative 13. And because I have multiplication, I need to divide now, as we learned from the first section, by 2.5 on the two sides. Okay, now 2.5 over 2.5 cancel each other, and this is X equal 15 over 2.5. We can do it this mentally, but we can use the calculator sometimes to get the answer. How many 2.5 in the 15? It's 6. Here is the solution. Now, if you go back to the title of the section, it's solving using multi-steps. So there is not only one step to find the solution. There are 2 steps or more. And that's clear that we add 13 to the two sides. This is step number 1. And then we divide by 2.5. So in this particular example, I did 2 steps. I just add and then divide. Okay? Okay. How about part B? Oh, let me ask, do you have any question, guys, so far? Is it clear, guys? Good. Do I go very fast? I'm always willing to hear from my students. If they feel that I go very fast, I can reduce my speed. Okay, it's my goal that I make sure that you get the idea and you understand what we are doing. Okay. Okay. So if you don't have any comments or questions, we can just move to the next example. Okay. If you look at B, I see I have a bunch of terms. Negative 12 on the left-hand side, 9x minus 6x plus 15. If you read the core concept here, it says simplify each side. We need to simplify. And what we mean by simplify? To reduce the number of terms as much as we can. Then use the inverse operation to isolate the variable. Okay. Now I feel, or if, I don't know if you agree with me, on the left-hand side, I just have one term. There is nothing to simplify. It's negative 12, just one single term. But you may agree with me that the whole work on the right-hand side, 9x minus 6x plus 15. I see I have 2 like terms that can be simplified. In other words, can be combined. Just think in your mind, 9x minus 6x. Okay, 9 minus 6 is a 3. So 9x minus 6x is simply 3x plus 15. This is equal negative 12. Perfect. This is equal. Now, I just reduce the number of terms on the right-hand side. I still need to keep working to solve for x. I still have 15 added to the x, the 3x, sorry, and the 3 multiplied to x. So it's a multi-step solutions. The solution, in order to get the solution, you need to do many steps. Now, the first step is, who can help me? What should I do now? I want to solve for x. Anthony, do you think, do you know what's the next step? should be? Just try.
Subtract 15.
Thank you very much. Yes, it's a plus 15, so I'm going to apply the subtraction property of equality to the two sides. Hey. So it's negative 12 minus 15, it's negative 27 equal 3x plus 15 minus 15. These are cancel each other, and then it's 3. And then the next step is to, because I have multiplication, I'm going to divide by 3 as we learned from the previous section. So that means negative 27 over 3 is negative 9. And 3x over 3, these are cancel each other, and we left with x. And this is the solution. Now I can decide to stop because I get a value for the solution. For x equal negative 9 is the solution. Yes. Okay. Is that clear? So this is another particular example how we need to do more than one step to get the solution. Sometimes I just need to add, multiply. I need to simplify. Sometimes I need to simplify and then add and multiply or divide and subtract. Okay. No questions? Okay. How about the third equation? It's 2 times parentheses 1 minus x plus 3 equal negative 8. And here it says I need to get the solution by 2 different methods. And this is a challenge, right? Not only to get the solution, no, you need to find the solution in 2 different ways. And that will make you more comfortable, more confident that you get the solution. If you get the same solution in 2 different ways, so you will be 100% confident that yes, this is the solution. So let's try with work with one of them, one of these methods. Okay, how about multiplying 2 times 1? This is method number 1. Let me just change the color very quick. So I'm going to think on the left-hand side that I need to simplify it very quick. So I have 2 times 1 minus x, and there's an important property is called distributive. What does this property say? It's called distributive property. And this property says that if you multiply a times the sum or the difference of 2 numbers like b plus c, then you can rewrite it as a times the first, a times b, and a times c, the second. Yes, this is called distributive property, and it's true. We can apply it anytime we have the left-hand side to get the right-hand side. And I see that I can apply the distributive property here. It's 2 times 1 minus x, so I'm going to multiply 2 times 1, which is 2, minus. I know the distributive is plus, but it can be replaced by minus. So if it's minus, then I just need to write here minus. So plus plus or minus minus, it's still 1. And then 2 times x, which is 2x plus 3 equal negative 8. Agree? I just apply the distributive property. This is minus. Let us simplify now very quick. It's 2. This is a number, a constant, plus 3. These are like terms. So I can combine 2 with 3. It is 5 minus 2x equal negative 8. Perfect. Now, it's a little more easier to solve this equation than the original one. I just need to do the inverse. It's 5, so I'm going to subtract 5 from the two sides, and this gives 5 minus 5 cancel each other, and this is negative 2x equals negative 8 minus 5, it's negative 13. Okay, so the next step here, because I have multiplication, and I need to divide the two sides by negative 2. This is the division property. So negative 2 cancel with negative 2, and then we get x equal negative 13 minus 2 over negative 2, sorry, it is 13 over 2, which is, oops, 6.5, or you just leave it as 13 over 2, it still works. So this is the solution using this method. I would like to ask you guys to try to think of another way, another method to get the same solution. Okay, do you agree? And I would ask you to share with me your solution for the next class on next Saturday. Yes, just try to find another method to get the same solution. Okay, I will just give you 1 minute to complete your writing. And if you have any question, please let me know. Done? Okay, let us move now to the second part of this. Yeah, we have now a word problem here, and it asks us to find the unknown, to find the solution of an equation. But first, we need to read the equation, sorry, the question, and try to find the equation and then solve it. So let us go over the question and see what we have and what we need to find. So it says, use the table to find the number of miles x. So this is unknown distance. You need to bike on Friday. See, Monday, Tuesday, Wednesday, Thursday, Friday. This is the first column, and the title is the days. And the second column is miles, and we know that on Monday, there is 3.5 miles, Tuesday 5.5, Wednesday it wasn't 5, so it's 0 miles, Thursday is 5, and Friday is x. So again, it needs us to find the miles x on Friday so that the mean number of miles by per day is 5. Let us first, before we go over this problem, and see what we mean by mean. I like the question, what we mean by mean. The mean, or sometimes we call it the average, is equal what? Is equal the sum of the numbers we have all over the number of these numbers. So I just need to add these numbers to find the sum. And then I need to count how many numbers I have. And then we divide the sum over the number of these numbers to get the mean or the average. Okay? So this is a formula. We always use it whenever we need to find the mean of a set of numbers, the average of set of numbers. Okay, so what we are given here, if you go over the question, we are given this table. We are also given that the mean number of the miles bike per day is 5. So the mean, first of all, is equal to the sum over the number of numbers. Okay, so what is the mean? We are given the mean equal 5, right? So this is 5. For the sum, I just need to find all the sum, adding all the numbers. And the numbers are 3.5, 5.5, 0.5, and x. So all what I need to do is just to add these numbers. 3.5 plus 5.5 plus 0 is the third number, plus 5. And don't forget to include the miles on Friday, which is x. So these are the numbers, and because I add them, I find the sum. Now I need to divide by the number of the numbers. How many numbers we have? It's not hard to count the days. It's Monday, Tuesday, Wednesday, Thursday, Friday. So there are 5 numbers. Oops. Okay, so this is the equation. It's not simplified. It's our job to simplify it and solve it, because the question says, find the number of miles x. So what is that number that I need to buy on Friday in order to get the mean of the 5 days to be 5? That's an interesting question. So now I'm going to simplify, to apply what we learned from the concepts we had. We just need to simplify here. It's 5 equals, it's not hard to add, 3.5 plus 5.5, it's 9, plus 0, still 9, plus 5 is 14, plus x, which is 14 plus x all over 5. Okay, so this is the equation. I just create the equation or construct it. Now the next step is to apply the inverse operations. Because I have division, this is the fraction line. It means division, so I'm going to multiply, oops, times 5, and then I should multiply the other side by 5 as well. Now 5 times 5 is 25, and this 5 canceled with this 5, and this is why we multiply by 5. We just apply the inverse. And then we left with 14 plus x. Perfect. Now, I still need to find x, but we know that 25 equal 14 plus x. All what we need to do is to do the inverse of 14, which is minus 14 minus 14. 25 minus 14 is 11. And 14 minus 14 cancel each other, and we left with x. So x equal 11. So this number should be 11. If you try to add these 5 numbers together and divide it by 5, you should get 5. And this is the end of the problem. So yes, we read the questions, we determine the given and the unknowns, and we create the equation. I think this is like the hardest part, is to create the equation. Whenever you create the equation, you're almost done. You just need to apply what we learned, simplify, do the inverse operation, and then get the solution, right? Any questions so far? Ethan, you have any questions? How about Austin? Okay, perfect. So we just learned how to solve the equation so far by adding and subtracting, multiplying and dividing, and this was in section 1.1. In section 1.2, we try to solve the same equations, but with more than one steps, the 4 operations together. And keep in our mind, every time we may have some word problems, like this example, to solve, to find the equation and then to solve it. Okay, now how about other type of equations? And this will be in 1.3, solving equations with variables on both sides. Okay, will be the third section we are going to cover today. And this will be the last section for today. And then I will show you the homework set that you need to work on the coming week until the next meeting, next Saturday. And if you have any questions on the homework, feel free to ask me on the next Saturday. I will discuss that with you in more details at the end of this class. Okay, so 1.3 says solving equations with variables on both sides. So if you read the title, we see that we have what? Variables on the two sides. We have the variables on the left-hand side and the right-hand side. And our job is to solve. If you look at the titles of the 3 sections, it's always start with solving. Solving is the most important keyword in the 3 sections, or the whole chapter maybe. To solve is to find the value of the unknown. So let us read what's the core concept here. It says, simplify one or both sides. Sometimes we need to simplify the 2 sides. Sometimes one of the sides are already simplified. So I don't need to be worried about it. Just need to simplify the side that has a bunch of terms. And then use the inverse operation to collect the variable terms on one side. So if you see x on the left-hand side and x terms on the other side, you just need to combine them, collect them in one side. And then isolate the variable, just solve for that variable. Okay, so this is like the procedure that we should do here every time we have the variables in the 2 sides. So yeah, let's do some examples and see how can we get the solution for this type of equations. If you look at the first example, A, it's quite similar to what we did before. 10 minus 4x equal negative 9x, except that I see the x terms in the 2 sides. Now you need to decide how to collect the terms in one side. I see negative 4x on the left, negative 9x on the right. I can move the negative 4x to the right, or I can move the negative 9x to the left. It's completely fine. It's up to you. You can either apply the first or the second way. You should get the same answer. So without loss of generality, I'm going to add the inverse. I'm adding because it's minus 4x, and I decide to move negative 4x to the other side. So this is why I add. It is the inverse. The same term, 4x. And because I add 4x to the left, I have to do the same thing on the right. Okay. So, see what we will get, what this step will yield. It's 10 minus 4x plus 4x. I see negative 4x and 4x cancel each other. So not only we can cancel the terms that have numbers, we can also cancel the terms that have variables. As long as I subtract the same quantity, then I can cancel it. So we left with 10 equal negative 9x plus 4x. That's not that hard. It's just negative 5x. And then I see that I left with one operation. It's multiplication. So I'm going to divide by negative 5, divide by negative 5. And see what's the benefits of dividing by negative 5. This is cancel each other. It's x equal 10 over negative 5. It's negative because plus and minus. 10 over 5 is 2. So it's x equal negative 2. This is the solution. Perfect. So we start with an equation that has x terms, the variables in the two sides, and that's not big deal. You just need to grab all the terms in one side. You can decide which side you want to move. You want to collect the x terms on the right or the left. It doesn't matter. Any questions? Okay. How about part B? I see there's like more complex equation, more complicated here. Wow, parentheses, fractions, x on the right, x on the left. So it seems that there are too many steps I need to apply. But don't worry, if you are organized, if you know what you are doing, for sure you will get to the answer. So it's math. As long as you apply the right property, the right steps, you will get the solution. So please look at this equation and see how it is complicated. How many terms do we have? Don't worry, we will now apply some steps and simplify it, and we'll see how it will be more easier and simpler. Okay, on the left-hand side, I have 3 times 3x minus 4. I think this form reminds me by the distributive property. Do you remember distributive property? Yes, it just multiply the number outside by each term inside. Let us see. So it's 3 times 3x, and this is 9x. 3 times negative 4, it's minus 12. Equals. So this is what I did on the left-hand side. I just applied the distributive property. Wow, I have another parenthesis on the right-hand side, and that suggests that I need to apply the same property on the right-hand side. It's 1/4 times 32x and 1/4 times 56. It doesn't matter if you have a number like 3 or 1/4, it's still work. I'm still able to apply the distributive. 1/4 times 32x, it's in other words, 1/4 times 32, or 32 over 4, and this is 8x. So the 8 comes from 32 times 1/4, or 32 divided by 4. And the second term comes from 1/4 times 56. Now 56 divided by 4, it's 28 over 2, or it's 14. Please, 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 if you see something not sure how we get it, please just ask, okay? It's my goal again to make sure that all of you understand what we are doing. Okay, so that's what we did. We just applied the distributive property and we get this equation. Now I still have a problem. I see 9x on the left, 8x on the right, the variables on both sides. And this is what the section title or indicates. But it's not a big deal. I just need to move one of the two terms to the other side. And usually we move the smaller term to the bigger terms. In other words, I'm going to move 8x because 8 is smaller than 9. I will move it to the other side. So it's 8x. So I'm going to subtract 8x from the two sides. So 9x minus 8x, it's x minus 12. There is nothing to do with minus 12. And 8x minus 8x, these are cancel each other, right? And then it's equal 14. This is what we left with on the right-hand side. The next step, it's to add 12 because it's minus 12. So I'm going to add 12 for the both sides. And I'm going to write the result on the new column here. Minus 12 plus 12 cancel each other. So the left-hand side left with x. Wow, this is the solution. X is alone. 14 plus 12, it's 26. And this is the solution for this complicated equation. And remember what I told you when we start with this problem. It's okay that we start with a complicated equation. As long as we are well organized, we know what we are going to do, we know what we want to get, so we simply will get the solution. Let's go over the work here, guys. The first step is the distributive property in the two sides. This is the first step. The next step is to collect the x terms on one side, and then we do the inverse operation to find the solution. And that's it. We are all set. Okay? How difficult is that question? Not difficult? Okay, perfect. Okay, let us, if you finish writing, you don't have any questions or something like that, we can move to the next part of this section. Yes, it's what? A word problem. That's something common. Every time we may have word problems that we need to work on to get the solution for this word problem. So let us try to read the question. And remember, every time we end with an equation. So if we can find the equation that represents this problem, that would be perfect. So first of all, we need to read. It says, a boat leaves New Orleans and travels upstream. Let me just highlight this word. Something new. Upstreams on the Mississippi River for 4 hours. Okay. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, interesting. So what do we have? We have two scenarios, two cases. The first travel and the return travel, okay? So let me just count them as number 1. That is the upstream. And what we mean by upstream, if you assume that this is the river, okay? And this is the water, how it moves or travels. It travels in this way. This is called the current, the water current. And use another color real quick. Okay. And because it's upstream, the boat goes in this direction. And this is what we mean by upstream, when we go in the against direction. And do you agree with me? Every time we are moving, we are traveling in the opposite direction of the current, our speed will be less, correct? The time we need to travel upstreams in the against direction will be more. And this is why the time here needs to travel is 4 hours. And this is what the question says, that it takes 4 hours when the boat travels upstreams. The other scenario, okay, let me just write it. Write it. Oh. Here. I will stick with the same colors. So what we are trying to do now, we try to figure out what's the question. I just consider one case. Now the second case, number 2, it's the downstream. The downstream here, I have again the river, and this is the direction of the current again, but the boat direction, because it's upstream, it's exactly same as the current direction. So it's in this way. Wow, both are in the same direction. So the time was less. It is 2.8 hours. This is a very important analysis. We need to analyze the question so we can obtain information and hopefully the equations. Now, you should agree with me, I hope that you agree with me, that the speed of the boat here is not exactly the same the speed in the second case. So, and this is what the question says. It says that the boat travels 3 miles per hour. Remember, 3 miles per hour is not a distance, it's a speed. So this is a speed. The boat travels 3 miles per hour faster downstream. So let S equals the speed at the upstream direction. And the question says that the boat travels 3 miles per hour faster. Faster means greater, bigger. So I need to add to the downstream, to the upstreams to get the speed for the upstream. So if this S is equal to the speed of the upstream, then S plus this quantity, 3, this will represent the speed of what? The downstream. Okay? So we just create the speeds for each case. I have the time for the first case, and I have the time for the second case. The good thing that the distance for the 2 trips is the same. This is called the distance. And it's not given, which is okay. I don't need to determine the distance. And this is the distance. It is still the same because this is when they go from right to the left, and this is when go the other direction. It travels the same distance. So the distance at the first case here is equal what? We know that the speed equals the distance over the time, right? This is the average speed or the speed formula. So that means the distance equal the speed times the time, or the time times the speed. But what is the time for the first case, the upstream? It is 4 times S. S is the speed, and unfortunately it's unknown, not given, or S. Okay, but I can describe the distance from the other case, the downstream. The distance here is again is the time times the speed. Now the speed is what? Is S plus 3, because I'm talking about the downstream. So it's S plus 3. But T is 2.8. So that means that the distance is equal 2.8 times S plus 3. Perfect. I have 2 quantities that describe the distance. The distance equals 4 times S, and the distance equals 2.8 times S plus 3. Because the distance is common, so these quantities are equal. And that means the 4S, let me just clarify this letter, this is S, is equal 2.8 times S plus 3. Now we can solve this equation. This is 4s equal 2.8 times s. I'm just applying the distributive property, plus 2.8 times 3 is 8 times 4. If you subtract 2.8 from the two sides, so, okay, just let me just do this on the other side. I just need more space. I will erase just the rivers here. So I'm going to subtract 2.8 s from the two sides. So 4s minus 2.8, it's 1.2 s. And 2.8 s minus 2.8 s cancel each other, and then we left with 8.4. And then divide by 1.2, two sides. So s equal 8.4 over 1.2 is exactly 7. And that's it. How far does the boat travel upstream? The upstream speed is s, and s equals 7. We are done. I know it's a little bit long question because I need to draw a picture and see what's the relation between the speed and the distance and the time, create equation, and then solve it. The last thing I want to mention here that the unit is speed. So it's mile per hour. Okay. Any questions so far? Please, if you have time over the coming days before the next meeting, go over these solutions one more time, because you will need to do that because you will have an assignment for the next meeting. It's due the next meeting, next Saturday. So you may need to go over these examples and the solutions. And if you have, or you feel you still not sure how we get this or that, just feel free to ask me in the next meeting. Okay. Now, there are like a very quick summary that we may need. Are you done writing, guys, before I move? Are you done? Okay. The summary is something nothing new, just we need to go over what we learned today. How can we solve the equations? Sometimes we need to apply the distributive property, and that's normal. When we have parentheses, we may think with the distributive property. Simplify, and what we mean by simplify, just to combine, collect the like terms together in one similar form. Also collect is the same thing. I just need to move the terms from one side to the other side and make sure that we simplify it. Isolate means that I need to make this variable alone, and then sometimes we can check our solution. We need to see, is that the number we get is true number? Is it the solution? Makes the equation correct or not? So these are just, usually we did some of them, sometimes we did all of them in order to solve the equation. Okay. The last slide is just identifying special solution of linear equations. What we have learned so far, we see that all the equations have solutions. And to be more accurate, it only have one solution. If you look at the equations that we discussed before, each equation has one solution. Is that always? No. Some equations don't have solutions. And some other equations have infinite number of solutions. So think like this. Sometimes we have no solutions, one solutions, infinite number of solutions. And I'm going to work with you over 2 examples here and see what we mean by that. For example, if you look at part A, it says, the question says identifying the number of solutions. We just need to count number of solutions. So 3 times 5x plus 2 equals 15x. There's nothing new. We just need to solve this equation, simplify it. It's distributive property. 3 times 5 is 15x. 3 times 2 is 6 equal 15x. Okay, I see x terms in the 2 sides. I'm going to move one of them to the other. So let me move 15x, this one to the right. So I'm going to subtract 15x, subtract 15x. This is what we used to do, right? But this term will cancel the 15x from the 2 sides. So there is no more x. We end with 6 on the left equals 15x minus 15x, 0, nothing. What? 6 equals 0. So this tricky equation ends with false statement. It says that number 6 equals 0, and this is incorrect. What does that mean in terms of solutions? There is no solutions for equations are not true. So this particular example explains that some equations don't have solutions. Okay? Let us do part B. -2 times 4y plus 1, distributive property, it's -8y minus 2 equal -8y minus 2. What? I see the 2 sides are the same. -8y, -8y, -2, -2. Since the 2 sides are the same, then it's a true statement and all the numbers are solutions. Okay, if you just try to add 8y, even you don't need to do that because the 2 sides are the same. Cancel each other, cancel each other. It's similar to the first example, the first equation, but the only difference that what we left with is -2. We know it's equal to -2, and this is true always. So this is the only difference between the 2 equations. This equation ends with false statement. 6 never equals 0, so there is no solutions. And the second equation ends with a true statement. Yes, -2 equals -2, and that's true. So that suggests that there is infinite number of solutions here. So this equation has infinite number of solutions, and we call it identity. Please stick with this word. Don't forget it. It's a very important word in mathematics. Okay. With doing these 2 examples, we are done with the first 3 sections, 1.1, 1.2, 1.3. Now, I'm pretty sure you have seen this table. You will see something like this every time we meet on every Saturday. This is your homework. It's just a table shows your homework. For example, on Monday, you need to go to page 8 to 10 and do these problems. And Tuesday, we'll do these problems. And on Tuesday, you need to go to page 16 to 18 and do these problems as well. On Wednesday, you need to go over these problems on these pages. And on Friday, you see there's no homework problems to do. You just have a quiz. And this quiz, you can find it at the end of section 1.3 in the textbook. So the quiz is just in the textbook. If you go to the textbook, you will be able to see the quiz there. It's just half page, okay? This is page 26, by the way. Okay, so this is your homework, guys. You just need to go over these problems on Monday, Tuesday, Wednesday, Thursday, and on Friday there will be a quiz. I will make sure after noon on Friday, next Friday, I will post the solution for all of these problems. So you will be covering all these problems within the weekdays, and then Friday I will post the answers, so you will have a chance to compare your answers with the model answers. And every time you have a problem, you are not sure, or you have a mistake or something not correct, we can discuss these problems and the solutions on the next meeting at the first 10-15 minutes. Agree? And the last thing I would like to recommend to go over sections 1.4 and 1.5. This is what we are going to cover next class. Okay? So yes, that's the end of the class for today. Do you have any question, guys, so far? Let me see your faces. All you. Anthony, any questions? Ethan, do you have any questions? Austin, how was the class today? Good? Okay, before we end the meeting for today, I just want to make sure that you will go over the homework over the week, and we'll discuss the answers next class on next Saturday, okay? Hey guys, if you don't have any questions, you are free to leave, okay? Okay. Bye. Have a good day.